Welcome! Sometimes you look at a math problem and it just seems like an impossible code, right? Well, today we are going to crack one of the most common codes in all of algebra. And I promise by the end of this, you'll see it's not some complex monster, it's really just a simple puzzle that you can absolutely solve with confidence.
So let's kick things off with a real-world puzzle, something you can actually picture in your head. Imagine you've found the perfect spot for a garden. You know the total area is a neat 200 square meters. That's a solid number, but you don't actually know the dimensions. And here's the catch, the little clue you're given. The seller tells you there's a specific relationship between the sides. Whatever the breadth is, the length is exactly 10 meters longer than that. Okay, so how do we go from these two pieces of info, the total area and that little clue about the sides, to the exact length and breadth? It feels a bit tricky, doesn't it? But there is an incredibly powerful tool in math that is designed for exactly this kind of problem. The very first step in solving any puzzle is you gotta understand the language it's written in. For our little land problem, that language is math. So we need to translate our clues into a single equation that we can actually solve. Let's just break this down. If we call the breadth x, because we don't know what it is yet, then our clue tells us the length has to be x plus 10. Simple enough. And we all know area is just length times breadth. So we multiply them together, make it equal to our area of 200, and with a little bit of rearranging, we get this. X squared plus 10x minus 200 equals 0. And this thing right here, this is what we call a quadratic equation. The name quadratic actually comes from quadratus, which is Latin for square, and it makes sense because our variable, x, is squared. That standard form you see, the ax squared plus bx plus c equals 0, think of that as the universal blueprint for every single one of these equations. So let's match our own puzzle to that blueprint. In our equation, the a is the number in front of the x squared, which in this case is just a 1. The b is the number chilling next to the x, which is 10, and c is that constant number at the end, which is a minus 200. Just identifying these three numbers is the first most critical step to finding our solution. All right, now that we've framed our puzzle as a proper quadratic equation and we've identified its key parts, we can finally open up our mathematical toolkit and find the right tool for the job. Now, there are a couple of ways we could tackle this. The first is factoring. It's like a little brain teaser where you try to find two numbers that multiply to negative 200 and add up to 10. It's super fast and pretty slick when it works. But sometimes, finding those numbers just isn't obvious. And for those tougher puzzles, we need a master key. So for a guaranteed solution, a method that works every single time, no matter how messy the numbers get, we need to bring out the most powerful tool in the whole kit. And this is it, the quadratic formula. I know, it might look a little intimidating, but really, think of it like a guaranteed recipe for a perfect cake. You just plug in your A, B, and C, our ingredients we found earlier, and the formula spits out the answer, every single time. But here's the really cool part. There's a secret hidden right inside this formula. It's a tiny piece of it that can actually tell you what kind of answer you're going to get before you even finish all the calculations. This specific chunk, the b squared minus 4ac, has a special name, the discriminant. It's the part that's living under the square root sign, and it basically acts like a crystal ball for our equation. It helps us discriminate between the different types of answers we might get. So here's the secret code. If that discriminant value is positive, you're going to get two different real solutions. If it turns out to be exactly 0, you'll only get one real solution. And if it's negative, well, then there are no real number solutions to your puzzle. It's this incredible predictive power packed right into the formula. Okay, theory's great and all, but let's get back to our plot of land. We've got our puzzle, we've got our master key. It is time to put it all together and finally figure out the dimensions of that property. All right, let's look at our equation one more time. We are solving for x, which, remember, is the breadth of our plot. So we just take our values, a is 1, b is 10, c is negative 200, and we plug them right into the formula. Now we just carefully follow the steps. 10 squared is 100, then we have minus 4 times 1 times negative 200. A negative times a negative is a positive, so that becomes plus 800. That gives us the square root of 900, which is a nice clean 30. And this leaves us with two possible answers for x, 10 and negative 20. Okay, the math give us two numbers, but this is where we have to use our common sense and bring it back to the real world. Can a plot of land have a breadth of negative 20 meters? No way, that doesn't make any sense. So we can confidently just toss that negative solution out. The only answer that's logical here is 10. And boom, there we have it. The breadth, our x, is 10 meters. The length, which was x plus 10, must be 20 meters. And just to check our work, does 10 times 20 equal 200? You bet it does. It all fits together perfectly. Our puzzle is officially solved. So let's just recap the big ideas here. First, lots of real-world puzzles can be translated into that standard quadratic form. Second, that quadratic formula is your super reliable, all-purpose tool for solving them. Third, remember to check the discriminant. It gives you a sneak peek at the answers. And finally, and this is a big one, always, always check your solution against reality. You know, what started as a simple land puzzle ended with this universal formula. This exact same tool can be used to calculate the arc of a ball flying through the air, to model business profits, or even design things like bridges and product packaging. These equations, they're kind of hiding in plain sight all around us. The only question is, now that you know how to crack the code, what will you solve next?